So before we get too complacent and think we actually understand what's going on here, let's show a couple of recent oddball results that seem to cast some doubt on this theory. These may go away, or they might fatally flaw everything I've just told you. Here is a very weird case from a very recent paper. This is a star. Here's its optical light. This is what you'd expect its spectrum to look like if there was no dust around it. But when it was observed between 2006 2008, the spectrum climbed up, so it looked like it had a debris disk around it. So you can see it infrared wavelengths. The energy was much higher than you'd predict.
Right.
However, they went back and re-observed it a couple of years later, 2011, and the points had jumped from here all the way down to there.
Right. So you're telling me in the case of 2 or 3 years that somehow this star completely cleared its debris disk? I thought the processes we were talking about were going to take tens of thousands of years at least.
It's pretty weird. It seems to have had a debris disk that went away. And as you said, you can't clear the dust out by any of the methods we've talked about that fast.
All right, so what do you think's going on here?
Damned if I know. People speculated maybe this infrared excess was due to something other than a debris disk to begin with. Maybe it's solar flare. Solar flares don't normally produce a spectrum like that, but...
Oh, okay, so it would be the solar flare would be up there, or the solar flare would have destroyed the debris disk or something. Who knows? All right. So you used the plural when you said oddballs. So this is one oddball.
Okay. Well, there's another family of oddballs, I guess. This is the European Space Agency's Herschel space mission, which is a bit like IRAS we talked about at the beginning, an infrared telescope sitting inside a duoflask to keep it very, very cool. But this one worked at much lower temperatures and much longer wavelengths, where it was incredibly sensitive. And what they discovered was normal debris disks, the spectrum was climbing up over here, out of around maybe 10 microns. This one's only gently climbing at several hundred microns. So what that's telling you is you've got a very cold debris disk. Because remember that wavelength at which something peaks depends on its temperature. A hot thing peaks over here, cool things peak further into the infrared. This would be a temperature of only 38 Kelvin, so an incredibly cold debris disk.
Well, Paul, that's all well and good, but this is a debris disk, we think, of dust. And I note that we're making measurements here at 1,000 microns. That's a millimeter. And you can't emit light that is longer in wavelength than your length. And so that would seem to indicate, to me at least, that we're not, dust isn't, a millimeter. That's like sand. So something's not right here.
Yes, I mean, the dust grains you've been talking about have been about micrometer in size, 1,000 times so small. So a micrometer can produce things out here, maybe 10 microns. But, 1,000 microns, you need to have sand. The trouble is, if you have something the size of sand, first of all, you need a lot more mass because you have much less surface area per unit weight. So the disk has to be much heavier as well as colder and further out. But also, if you have an orbiting disk of dust and we produce it the same way, where we smash big things together, what would normally happen is you smash big things and they make slightly smaller things, they get smashed to make smaller things still, until you end up with things so small they get blown away. So most of the area should end up in the smallest things that can survive without being blown away. And we're talking about very cold a long way out, so even very, very small grains should be able to survive out there. So most of the radiation should always be from the smallest grains that can survive being blown out, which would be a micron or even less than a micron in this case.
All right, so it does seem not to add up. For some reason, there's literally a sandbox around the outside of this star, or something else other than what we think is causing this emission.